Right, in this video, I'm going to be proving to you the derivatives of sine and cosine. Now, in class, you've probably already learned that the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. But I'm going to show you why this is true, using some trig identities and some of the special trig limits that you may have seen me prove in an earlier video. All right, so we'll start off with the derivative of sine x, which is cosine x. And what I'm going to do, I'm going to start with the definition of the derivative. Remember, the definition of the derivative is the limit as h goes to 0, f of x plus h, which in this case will be sine of x plus h, minus f of x, sine x, all divided by h. Okay? Now, in order to kind of deal with the sine of x plus h, we're going to need an angle addition formula from trigonometry, from your pre-calculus class. So I'll bring that in just to remind you of what you may have forgotten. And there you have it. So the sine of x plus h is going to be sine of x cosine h plus cosine of x times sine of h. We don't really need the cosine of x plus h until later when I show you the derivative of cosine, right? It would make sense that I'll have cosine of x plus h minus cosine of x divided by h, taking the limit as h goes to 0. I just won't need that quite yet. So what I'll do is I'll rewrite that limit in black using the angle addition identity. All right, so there you go. I moved the cosine of x plus h out of the way because we don't really need that. And okay, I replaced sine of x plus h with sine of x cosine of h plus cosine of x sine of h, and I still have that negative sine of x divided by h. Now what I should probably do is take the second and third terms of that sum in the numerator and switch them. So I have sine of x cosine of h minus sine of x plus that cosine of x sine of h. Okay, because what's going to happen is I'm going to want to factor out 1 power of sine x. All right, so there we did that. And now we're going to want to factor out 1 power of sine x. So we can do that. We'll be left with sine of x times cosine of h minus 1. And then we'll have plus cosine of x sine of h, and then we'll all be divided by h. So it won't look too different. We'll just factor out a sine of x from the first 2 terms in the numerator. There we go. And now the next thing I'm going to do is I'm going to kind of distribute that 1 over h that's implicit when I have an h in the denominator to the 2 different things that I'm adding together. Okay, if you're in my class before, I kind of call this like the heart-shaped thing because I'm going to have sine of x times cosine of h minus 1 divided by h. And then in a separate fraction, I'm going to have cosine of x sine of h all divided by h. Right? So that's what kind of why it's the heart-shaped thing. Either way, it's just a distributive property. Except when I did that, I did it kind of in a clever way. I saw that I've got this cosine of h minus 1 and this sine of divided by h, and I've got this sine of h divided by h, and these are related to our special trig limits. So I took that sine of x and that cosine of x and moved them out in the front. It's kind of like, you know, something we're multiplying by. Now, what this is, okay, remember that maybe if I factored out a negative 1 from, you know, this thing that I'm highlighting in yellow, what that will do, we'll call this negative sine x multiplied by 1 minus cosine h divided by h. And I'm taking the limit as h goes to 0. Now I'm ready to go because the things in parentheses are my special trig limits. Okay? The limit of 1 minus cosine h divided by h as h goes to 0 is equal to 0. Right? So this is equal to 0 plus the limit of sine h over h as h goes to 0 is going to be 1. So I've got 1 times cosine x. So I show that the derivative of sine is equal to 0 plus cosine x, which is what I'd set out to show in the first place. All right, next we're going to look at the derivative of cosine x, which you may have learned in class was negative sine x. Okay, so I'm going to start off the same way with the definition of the derivative. So that's the limit as h goes to 0, f of x plus h minus f of x all divided by h. And I'm going to apply an angle addition identity. Okay. Now this time I'm only going to be interested in cosine of x plus h. And I think I'm going to be a little smarter. I'm going to just take what I already wrote and put that into the fraction. Okay, so I'm just going to get rid of the angle addition identity, you know, the words. I'm going to get rid of sine of x plus h. And I'm going to take what cosine of x plus h equals, and I'm going to put it into that limit. Okay, now I'm going to do the exact same thing I did in the last one when I was proving the derivative of sine. I'm going to rewrite this so I have cosine x cosine h minus cosine x, so I can set up for factoring. Let me do that right now. All right, and now I'm going to actually factor, so I'm going to have cosine of ax times cosine of h minus 1. And I'm going to do the same thing. I'm going to use the heart-shaped thing. I'm going to distribute the h to each of these factors, right? I'm going to say that this is now, the limit as h goes to 0, and I move that cosine x out to the front. Cosine of h minus 1 divided by h minus sine of x multiplied by sine h over h. So much like the last one, I could look at this and say, okay, this is a little different from what I have seen in my special trig limits, but it's the negative of something that's going to go to 0. So regardless, it's going to go to 0. So what I have is 0 minus sine of x multiplied by the limit as h goes to 0 of sine h over h, which I showed you in the previous video, was 1. Okay, so I've got 0 minus sine x is negative sine x, okay, which is what I had set out to show that the derivative of cosine x was in the first place.